Hello and welcome back to App for You. In this particular video, we will be discussing about a problem which will focus on inserting a node in a sorted linked list. Alright, so this is a very basic problem of linked list, right? Quite simple, but still for the sake of completion, as I don't want to leave any stones unturned, I have picked up this topic, right? So how do we deal with this problem? So we basically have a sorted linked list. Suppose we have a linked list which is sorted in ascending order. For example, we have elements like 1, we have elements suppose 2, suppose we have 4 here, we have 5 here and 6 here. Okay, it can be anything, but it should be in sorted order. Suppose I am taking ascending order. Okay, now I am interested in inserting a node with value 3 in this linked list, right? So obviously it is already known that this node should be inserted in this position, isn't it? Because it is greater than 2 and it's less than 4. So how to solve this particular problem? Okay, how can we successfully insert this node inside or between these two nodes, right? This is what the problem basically tells us. Okay, so how to deal with this problem? So let us quickly understand and develop an intuition about solving this particular problem. Okay, this is very basic problem and I will be hence very quick in dealing with this. So as we said, we have a linked list which is sorted in ascending order and has the value 1 2 4 5 6. This is the last node of the linked list and hence it is pointing to null, suppose. Okay, and this is the head pointer. Great. And we have a node with a value 3, a new node. Okay, we have to insert this new node, okay, in this position. So what is the technique for doing that? So what will we do is, initially we will take two pointers, a pointer P and a pointer Q, and we will point it towards the head position. Okay, wherever the head pointer is pointing to, that node only P and Q pointers will also point, right? And what will we do? We know that we have to insert 3, right? So basically we will insert in that position such that the value 3 is greater than a node before it and less than the node after it. Alright, so basically we can say that while P not equal to null, isn't it? And P should be, less than the value n that you are passing. Okay, suppose n equal to 3 of this node, right? We have to insert 3, so n equal to 3. So while P's data is less than n, okay, which means what will we do? Initially, if you look at this particular point, P is not equal to null is true, great, and P's data is nothing but 1, and 1 is less than n, isn't it? And because n is 3 here, so what will we do? Inside the loop, we will say Q is equal to P and P plus plus. You will understand why we are using Q pointer later on. So Q remains here only, P moves to this point, right? Q remains here only, P moves to this point. Again we come back. Again P is not equal to null, right? Because we already have a valid node here. And P's data, which is 2, is less than n, and n is 3, right? So basically, which means that we again have to say Q equal to P. So Q will now take this place and P will move forward. P comes here. Now again we go back. P's data, P is not equal to null, valid, and P data less than n. But P's data is 4, which is greater than 3. So basically we will not enter in the loop. We come outside of this loop. So far what we did? So far we have successfully reached the point of insertion, isn't it? Because we now have found out what is the point where we have to insert the node. So basically you can see the pointer Q and pointer P have already landed in their specific positions, and both are important now. Now we will see how to deal with it. Alright. So now P has already landed here, right? The third position, because I want to insert it in third position. Q is present in the node just before P, in this position, okay, in this node. Now I have to insert the node 3. What will I do? First of all, I want to insert a value 3. So first of all, I'll create this node, isn't it? I will create this node 3 using malloc. So this node will be created. Once this node is created, I will insert the value which I want to insert. So 3, right? And now we know that we want to insert this node in this position, okay, in this particular position. So for that, the next of this new node, the next pointer of this new node should point to P, right? The next pointer of this new node should point to P, because it is going to bridge the nodes 2 and 4, and the next pointer of this node Q should now point to the new node, right? So you can see successfully now this will no longer exist, and we have successfully inserted 1 2 and we have inserted 3 in between 2 and node 4, right? So this way, I hope you understood why Q was important, because once P reaches the node 3, now we know that we have to update the node previous to P That means we want to update the next pointer of the node previous to P, and it should point to the new node, right? Hence it was mandatory for using a Q pointer. Okay, that will basically keep track of the previous node so that we can successfully update its next pointer to the new node. Alright, so this was a theoretical explanation. Let us quickly jump into the coding part. So if we just jump into the coding part, we can see how it actually works. So basically this is the problem statement. We want to insert a node in a sorted linked list, right? So I'll share this particular code in the drive, and the link will be provided in the description box. So basically this is a basic definition. We are defining the structure of the node here, and initially initialization head to null, and an insert function to basically create a linked list, and this particular function print linked list will basically print all the elements of the linked list, right? But now what is the function that I created? This is the function that I am focusing on, an important function that we created just now. That is, we want to insert a value into the sorted linked list. So let us explain the function. So we will receive a head pointer and we will receive the value n which is to be inserted. Okay, initially the counter is equal to 1. Okay, just ignore this, this is not required. So initially, as we said, P and Q will point to the head node, right? P and Q will point to the head node. Then we will have a while loop. What will we do? We will check whether P is a valid node and P's data is less than n, right? Just now we explained it. And if it is so, Q will point to P and P is equal to P next. This loop will proceed as long as, you know, suppose we had the value 1, 2, 4, 5, 6 and null, right? So initially P and Q were at this particular point. This is the head node. So in the very next loop, since 2 is less than and we want to insert 3, 2 is less than 3, so basically P comes here, Q remains here only because Q takes the value of P. And in the next position, what will happen? 1, 2, okay, we want to insert 3. So again, since 2 is less than 3, so we are again doing Q equal to P. So Q will come here and P is equal to P next, P comes here, isn't it? And again, now P's data is basically not less than n because 4 is less than n is false, right? So basically we will not enter the loop anymore. We come out. When we come out, we create a new node. We create a new node. Okay, we keep the value 3 here. And what do? New node's data is equal to n. We did that. New node's next is equal to P. So basically now this will point to the node P. This point, because P is right now at this particular node, isn't it? And Q's next is equal to new node. So Q is basically at this particular node now. You can see Q is at this node. So this next will be equal to the new node, right? This is successfully created, and finally we will return the head node. Fine. And that particular node that is returned, that is the head node that is returned, will be received here, somewhere here, you see. We are receiving it, and finally we are printing the linked list. So let us quickly run this particular problem. Very simple problem, isn't it? So let us just quickly run this problem. Alright. So number of nodes, suppose 5, and we want a linked list in ascending order, right? So suppose we have okay, 5, 4, 2, 1, 0, right? Yeah. And suppose now we want to insert 3. So we can successfully see that we have inserted node 3, right? Here you can see we have inserted node 3. We have inserted, this was our linked list that we created. Okay, this is pointing to null, and we want node 3 to be inserted at this position, and you see it was successfully inserted between 2 and 4, right? So that's all about the problem. I hope it was quite intuitive. Very simple problem, I know that, but still, for the sake of completion, we have covered this topic. Right, so that's it. In case of any doubt, please put your doubt in the comment section. The code will be shared in your drive. And thanks for watching. Please like, share and subscribe.